software side of things, we have 2 Raspberry Pis connected to a custom PCB that allows them to easily connect to sensors all throughout the car. These sensors are battery monitoring sensors. We have temperature sensors on the motor and batteries and anything that could overheat. We have speed sensors on the wheel so we know how fast we're going. We have orientation sensors on here so we know the orientation of the car. And we have a LiDAR up here, 360 degrees, so we know about our surroundings. The biggest change to a normal go-kart that we made this year is in the steering. Normally you would have a steering wheel or something similar to control the go-kart. But we wanted to have the Raspberry Pis be able to control it so that they could make adjustments to keep the driver safe or even do some basic levels of self-driving with LiDAR and other sensors. We found that the easiest way for us to do this was with a servo here and an Xbox controller, because we're all used to using Xbox controllers to drive things in computer games. The next major thing we wanted to work on was having improved data logging. So with all these sensors, they feed into the Raspberry Pis, which then helps the Raspberry Pis make decisions. But the data also gets sent off to our server. From there, it gets stored for further analysis via a web portal. So we can graph the data, look through trends in the data, and see what's going wrong. The final part of the software in this project is all to do with modernising the way we interact with the car. To configure options such as motor output, sensitivity of steering, we have a phone app which sends config files through to the Raspberry Pis. To configure Xbox controllers, we can all use our own controller so that we can set our button preferences and stick settings. And to give data to the driver while they're driving, we have the dashboard. This is running as an Android tablet running an app which connects through to the Raspberry Pis, displaying live data about everything that the driver needs to know, including what's around them from the LiDAR.
On the front half of the kart we have a 40 Nm servo. This is a rather powerful servo which allows us to steer with high precision and a large amount of speed. In the centre of the kart we have a shock absorber which is connected via a pin and a large pin that runs through the centre of the kart. This allows us to disconnect the two halves of the part for ease of manufacturing and transport. On the back half of the frame we have our brushless DC motor. We also have a torque converter and plasma cut brackets. We also have 4 22 watt-hour batteries and a speed controller.